It's Saturday, November 9th. This is your skill check number 8. In the first scenario, Sakwe claims to be psychic, and Kiboko is going to put this to the test. So what Kiboko plans to do is to collect some data and produce a confidence interval for P, the probability that Sakwe guesses correctly the color of a randomly drawn playing card. And Kiboko wants to produce an interval that is no more than 5% in width. In other words, the margin of error is no more than 2.5%. So the first question just says that there are 4 conditions under which we can assume that the sampling distribution of p hat is approximately normal, and here you are to explain why these conditions are satisfied. So the first condition, randomness, is satisfied because each time Sakwe guesses whether the card is black or white, the outcome is uncertain, and that's the very definition of randomness. Secondly, we have independence because it is reasonable to assume that the probability that Sakwe's guess is correct on any given draw is not influenced by the outcomes of previous guesses. The 10% condition is satisfied because in this case the population is not finite, and we don't need to worry about the 10% condition when the population isn't finite. The success failure condition here is a bit tricky. So since we have no data yet, the only way to check this condition is to compute the expected number of successes and failures. So it is reasonable, for example, to assume that Sakwe can guess at a rate no greater than chance. So once we have a sample size n, this condition can be satisfied as long as 0.5 times n is at least 10. So we have to figure out what our sample size is first in order to determine whether this condition is satisfied. The next question is about the sample size. It says, how big a sample does Kiboko need to make the margin of error no more than 0.025? And so here we use that equation for sample size. So that Z star percent, that's just the critical value, which depends on the level of confidence. The P guess is your best guess at what the probability of success is, and ME in the bottom there is your margin of error. So we can plug values in. We're to construct a 95% confidence interval, and so the critical value is 1.96. P guess is 0.5, 1 minus P guess therefore is 0.5, and the margin of error is 0.025. Calculating, we get a sample size of 1,537 after we round up. And so we can just pause here for a second and ask again, is the success failure condition satisfied? Well, certainly, because we have a really big sample. And so clearly, if the true probability of guessing correctly is 0.5, then clearly we have much more than 10 successes and much more than 10 failures in expectation. Meaning that's what we expect to see, way more than 10 successes and way more than 10 failures. Okay, so here we're going to actually construct a confidence interval. So suppose the proportion of draws that Sakwe was able to correctly guess was 0.54. We're to construct a confidence interval using the sample size that we just looked at. And so here we can first calculate the margin of error. The margin of error is a critical value times the standard error of p hat. Critical value for 95% is 1.96. The standard error is p hat times 1 minus p hat divided by the sample size, and then you take a square root. And so calculating all of that, we get a margin of error of 0.0249. And just notice, initially we calculated a sample size that would ensure that the margin of error is no more than 2.5%. And here, once we have the data, we see our margin of error is just a little bit less than 2.5%. So that kind of demonstrates that the calculation for sample size does indeed give us what we want. So the confidence interval centered at p hat 0.54 is our best estimate of the probability that Sakwe will guess correctly. Our margin of error is 0.0249, and so 0.54 plus or minus the margin of error gives us our lower and upper bound of our confidence interval. And so finally, the interpretation. Since the 4 conditions under which p hat is approximately normal hold, we are 95% confident that the probability that Sakwe correctly guesses the color, red or black, of a randomly selected playing card is between 0.5151 and 0.5649. And we can go on to say that since the interval is greater than 0.5, there is evidence at the 95% level of confidence that Sakwe can correctly guess the color of a randomly drawn playing card with a probability greater than chance. Next scenario, here we're imagining that Jusufu owns a herd of 840 cows. Once a year, he takes a random sample of cows and tests them for various bovine diseases. This year, he aims to estimate the proportion P of cows in his herd that are sick by constructing a 90% confidence interval with a margin of error no more than 3%. Historically, the proportion of sick cows has been 12%. So the first question is, how big a sample does Jusufu need to make the margin of error no more than 3%? So going back to that equation for sample size, in this case, our critical value is 1.645 because we're to construct a 90% confidence interval. Our best guess for the probability of success here being a cow does have a bovine disease, is 0.12. 1 minus that is 0.88, and the margin of error we're looking for is 0.03. So putting those numbers into the equation, we get a sample size of 318. So next we're to explain why Jusufu cannot use the sample size that we just calculated. And the answer is simple. The sample size required to obtain the level of precision that Jusufu wants, that sample size was 318, is much more than 10% of the population of 840 cows. So the 10% condition would be violated if Jusufu took such a big sample, and we would not be able to use the normal approximation for the distribution of p-hat. Right, so by the way, what is the biggest sample size we can take? We have 840 cows. The biggest sample size we can take is 84 because that's exactly 10% of the population. Next, assuming that the proportion of cows with a bovine disease is 0.12, how big a sample should Jusufu take in order to satisfy the success-failure condition? Right, in other words, how big does the sample have to be so that we can expect to see at least 10 cows that are sick and at least 10 cows that are healthy? And so here, the sample size n must be large enough to make 0.12 times n, times the sample size, at least 10. And so that means we need n to be at least 10 divided by 0.12, which turns out to be 83.33. Rounding up, we see that the minimum sample size is n equals 84 cows. So we need at least a sample size of 84 to satisfy the success-failure condition. So in this scenario, n equals 84 also happens to be the maximum sample size since it is 10% of the size of the population. So that's just the way it happened to work out in this case. It won't always work out that way. So next, while Jusufu was working on all of these calculations, his wife Amina tested 84 randomly selected cows and found that 9 of them had a bovine disease. Construct a 90% confidence interval for the proportion P of 6 cows in their herd. So once again, we can start by calculating the margin of error. The critical value is 1.645 because it's a 90% interval. P hat is 9 divided by 84. That's 0.1071. 1 minus that number is 0.8929, and the sample size is 84. So performing this calculation, we get a margin of error of 0.0555. And so that gives us an interval centered at 0.1071. That's our best estimate of the proportion of cows that are sick. The margin of error is 0.0555, and so the p-hat plus or minus that margin of error gives us our lower and upper bounds of the interval. And so our 90% interval starts at 0.0516 and ends at 0.1626. Question 5 is to interpret the confidence interval that we calculated. And so we just say Since the 4 conditions under which p hat is approximately normal hold, we are 90% confident that the proportion of cows that are sick in Jusufu's herd is between 0.0516 and 0.1626. We might go on to say that we are 95% confident that as little as about 5% and as much as about 16% of Jusufu's cows have a bovine disease. And so that looks like it. Yep, that's it. So thanks for watching. If you have any questions, don't forget you can ask me in class, send me an email. You can put a question into the comment of this video as you wish. Bye for now.